Okay, when you do questions 19 and 20 on your test, the first thing that you have to do, you need to go and get the addresses to A, B, and C original, so that when you rotate and you turn your page, you can regraph them using those coordinates. Who can raise their hand and tell me what's the coordinate in A? A original. Take a quick look, so I'm not doing all the work. Levi, what's the coordinate in A original?
-4, -3.
-4, -3 rocks. Thank you. Who wants to tell me the coordinate in B? Trinity?
-2,
-2, -1. And yes, don't forget my little negative sign here, sorry. And last but not least, who's got C? Calvin?
-1, -4.
-1, -4. Now, the way we taught this, the first one says I want a 90-degree counterclockwise rotation. Now, clocks turn this direction. Counterclockwise turn this direction. So, if I'm thinking about it, my work in my 90-degree counterclockwise needs to show up here. So what we've done is we've said rotate your page so your work shows up there. The confusing part, 90 degrees counterclockwise means turn your page 90 degrees clockwise. Now what's a little tricky, these original coordinates, I gotta still be able to see, so I gotta turn my neck to be able to see them. I want to go graph I want to graph A at -4, -3. 1, 2, 3, 4. 1, 2, 3. That's my point A. Now, yeah, I'm kind of fancy when I write my A on its side because I know I'm going to be flipping my page later on. B should be at -2, -1. Right here. C is at -1, -4. 1, 2, 3, 4. Now, I'm not even close to being done with this question because what I'm doing is I'm rotating my coordinate grid to now figure out what the address and coordinates are after they've been moved. So this is all my ones that have been moved. I rotated it 90 degrees counterclockwise. Yeah, it's tricky. You gotta rotate your page 90 degrees clockwise. You're going in reverse. That's why you're doing that. So now I have A prime, B prime, C prime. Who wants to tell me what the new coordinates for A prime are? Anybody? Come on. Zach, what do you got?
1, -2.
No, A, I'm sorry. Start with A first. A as... Nope, that's where B is. Rory.
4, -1.
1, 2, 3, I think. No. Courtney.
3, -4.
3, -4. Who's got my new coordinates for B? Next.
1, -2.
1, -2. Who's got my new coordinates for C? Andrew.
4, -1.
4, 1, 2, 3, 4, -1. Now, it is kind of cool. You got the right answer. Go take a look. My X and Y swapped. 3 became positive. 4 stayed the same. My X and Y swapped. Y became positive as an X. X and Y swapped. You can look and see for those particular kind of tendencies that happen. Now, my last one, thrown in a different color. A rotation of 180 degrees does not, you don't have to worry about clockwise, counterclockwise, because if you're turning a half a turn, it doesn't matter which way you go. So flip it upside down. Now, you need to still see this though. A is going to be at -4, -3. -4, 1, 2, 3, 4, -3, 1, 2, 3. Now, I got to be pretty talented to put my A upside down and realize that it's actually written upside down. B is at -2, -1. And C is at -1, -4. 1, 2, 3, 4. Now, what we're doing is we're turning our page, graphing it with its original coordinates on a different grid. So we're letting the grid and the spinning of the actual page do my work for me. So when I flip this all the way around, I have new coordinates again. I've got A, B, and C written out differently. Who's got my coordinate for A this time? Trinity. 4, 3. Who's got my coordinate for B this time? Yeah. 2, 1. And who's got my last coordinate for T? You guys are good today. Trevor.
4, 1.
C? Not 4, 1. 1, 4. Now, it's kind of cool that yes, we show our work by turning our page. Plotting it in the same exact counting of my original coordinates on a different axis. And then you got to flip it back and then re-grid it according to where the new location